Hi, everyone. Good morning. Thanks for coming to our talk. It's great to see you all today. It's really awesome to be here, first of all, at XConf. This is my first XConf. I'm Minette Mangajas. I'm a systems design strategist based in Berlin.
Hi, I'm Andy Simmons, a data scientist based out of London at ThoughtWorks. And essentially, we met over a panda and a raccoon making a comic strip during a Green Software Foundation hackathon earlier this year. And this is something they run every year. This year, it was focusing on a system they're developing called the Impact Framework to help measure your software. And that's what we're going to speak about today. But I think from that last keynote where where Trish was talking about tests and things like that, and Chris spoke about it too, teams want to do tests and some teams leave it till the end and things like that. But I wonder how many teams you've been on have actually measured the impact of your software as well. And so the Impact Framework is a way to start getting into that. There's other tools as well, which we'll touch upon. Without further ado, we can kind of get started with the kind of high levels of what we're going to cover today. We're going to hopefully, first of all, take you through end with a high-level technical introduction to the Impact Framework and how you can just get started and just try and demystify it a little bit. So some of the terms you might come across you're not scared about, and you can just kind of check it out when you get back to your desk.
Yes, that's right. And we have a two-part mission today, right? So the first one is we're going to talk you through the Impact Framework so that you can go feel comfortable as you open it up and try it out. It's super powerful. We're super excited about it. And then second is also to give you just a few pointers for how to communicate and influence the importance of measuring your impact to your teams and your stakeholders, because this is actually the number one blocker for doing this kind of work. And I think for the most part, most people these days understand that we have an issue, right? We have a problem that we need to solve. We need to solve it, but the hill to climb over that, when to do it, how to do it, we still need to get our stakeholders on board so that they understand the urgency that we need to do this now. So, having said that, let's start with the pointers. So how do I engage stakeholders? And if they don't get it, then we've only won half the battle. And the reason why we're starting with this is because today in our talk, we're going to try to also demonstrate how to do these. So we're going to try to use storytelling and metaphor just to see, okay, how might we explain this to them in terms that they would understand? Maybe to relate it to experiences that they have in their own life so that they really kind of get it in their own way. And then the second thing that you want to do when you're talking to somebody about this, maybe it's your product or project manager, maybe it's the rest of your team, is to understand and be able to articulate what problem are we solving here. So depending on who this is, it might be, okay, does it save us time and money if you're talking to the business? Can we use it in our marketing, right? Can this be communicated to our customers and our clients in a way that excites them about what we're doing? Third is, will it make our business more resilient? And this is really taking the long-term view, right? I've heard so many people say, we can't do business on a dead planet. And this is really, really true. That might seem far off, but it may not also be that far off, actually, depending on who you talk to. So it's really important to think about business resilience, because as we've seen in the last few years, the economy goes up and down, we have pandemics, we have wars. How can we make our business resilient? So this is one of the ways that we do that. Third is really know your audience. Who am I talking to right now? Who is this individual? What's in it for them? What are their measures of success? Personally, maybe, who are they, on a personal level? Professionally, what are their goals professionally? How does this help them get there? And then also for the business, right? What's in it for the business? What are the business measures of success? And how does this point directly to that? So understanding these three things can really help to engage in terms of, okay, why should we do green software? And this is really, really important for us right now. The context. Now we dive into the why. How many people have heard of the European Green Deal? Oh, a couple people. All right. Well, you will all have heard of it today. So the European Green Deal is super exciting. Actually, the EU Parliament, a couple of years ago, decided that they want to make Europe the first climate-neutral continent on the planet by 2050. So this is what, in 25 years? That's not that long. What do we have to do to become climate neutral? Think of all the things, right? This is huge. So the EU Green Deal is a set of policies. It comes with lots of different things. It affects every segment of the economy, and it also makes sure that we not only measuring our pollution, but we're also doing things like reducing biodiversity loss, and we're also socially responsible. So our business is good for people. Our business is good for society. And we have to measure all of these different things in order to consider ourselves successful for the European Green Deal by 2050. So this is a super high, super ambitious goal, but actually this is also a necessary goal in order to be able to maintain our quality of life that we have today. So second, so then, okay, as software developers, what role do we play in this moonshot? What can we do? And actually, does IT even contribute to climate change? So, it may seem really, really abstract to a lot of people, but there are really concrete measures and really concrete connections between IT and climate change. So, a couple of statistics. The internet currently produces, according to the BBC, this was from actually a couple of years ago. The internet currently produces approximately 3.7% of global carbon emissions today. So that's actually growing quite a lot. It's actually grown since this study was done. And we'll talk a little bit about why, but you can probably guess AI has a small part in it. Data centers consume about 2% of global electricity today. And by 2030, they will consume as much as 8%. So this is actually something that's also growing much faster than even this statistic can capture here. By 2040, it is expected that the IT sector will account for 14% of the world's carbon footprint. 14%, IT. Right, so that's all the apps on your phone, the internet, everything, all kinds of applications we use in our industries, and that will only grow, and that's up from just 1.5 in 2007. So that's a growth rate about 6.7% on average per year. And I think that will also escalate. So this is from the Harvard Business Review in 2020. So some ground sort of foundational concepts here. So what is green software? So when we talk about green software, there's about 3 pillars generally that we need to understand. So we have energy efficiency, we have hardware efficiency, and we have carbon-aware computing. So energy efficiency, obviously, is when we're really smart about when and where we use energy, using only the energy that we need. So as we're designing our systems, we always constantly ask ourselves, okay, how can we actually make this more efficient? Are there ways in which we can reduce the waste? Second is hardware efficiency. So this has to do with designing elegant systems so that we use only the hardware that we need, and then we maintain these systems longer. So we're not necessarily just updating systems and changing them, throwing them out every couple of years. We're really thinking long term. How can we make the machines that we're purchasing today or that we're commissioning today work for us for as long as possible? And then when we're ready to decommission them, we're doing that in a responsible way so that those resources can go back into the resource stream so that we're contributing to circular economy. And then the third is carbon-aware computing. So this is when you're creating your bases, you're looking at your algorithms, and you're thinking about, okay, how do I build in ways that enable them to measure the impact that they have on the environment? So you're building in systems of monitoring, modeling, and measuring throughout. And you're doing that so that you can increase efficiency all throughout the way, and making that part of your testing, part of your building, and all of these kinds of things. So, having said that, so let's look at a couple of specific examples. So now we're going into the storytelling bit. So just out of curiosity, how many people are gamers in the room? Do we have any gamers? Yeah, really proud, super. So don't worry. I think AI also actually contributes quite a lot more than gaming, but we will look at how gaming actually has an impact on the environment and how can we mitigate that impact. Because gaming is not going to go away, it's huge, and we want to continue to game. So just for example, a simple word processor may only use 10% of a CPU's capacity, but when you have a game that's running on your CPU or your GPU, then that can go up to 90% utilization. So it's really important to understand that when that happens, then you have a wattage that increases on your computer, which means that it's taking up more energy, draining more energy from the power grid. So for example, how many of you remember Pokemon Go? From 2016. All right, Pokemon Go, for those of you who don't know, is a mobile app game. Millions of people downloaded this game and started to scan the environment using AR for virtual creatures. And there's actually a correlation because it uses GPS and it uses a lot of data connectivity. There's actually a correlation to spikes in the demand for energy and surges to data centers to the use of and the use of the game in general. So so what was it? Whenever there were spikes in times when people would be using the game, all of the energy grid was strained. So this is a really concrete example of how gaming on a large scale can really impact the environment and why it's really important for us to think about GPU, what's the word?
So the usage
utilization. Yes, thank you. Yeah. So we go from gaming to data centers. So imagine that you're in a data center and there's thousands of these CPUs, right? So you understand that one server uses a lot of energy, but if you multiply that by thousands and hundreds of thousands, and some data centers have over 1 million, you can imagine that everything that you save on that small server, every little bit of waste that you might have will be maximized or magnified by thousands, hundreds of thousands, and 1 million. So it's really important for us to think about, okay, what can we do when we're creating our systems and designing our systems to minimize waste as much as possible? And we want to do this in terms of minimizing the loss in terms of heat, and also minimizing energy consumption, and also doing something called demand shifting. Now, demand shifting is shifting where and when, so temporal and spatial, where and when we're actually drawing energy. So for example, we might have a choice as to when we're running our programs. So if we know that there's more renewable energy, for example, from wind farms or solar farms that are available during the day or during the evening, then we can run certain programs at those times so that they're drawing energy at a time when there's more renewables in the grid. And then maybe running certain programs at different times when we know that there's more fossil fuel in the grid. So it's really being smart about and also self-educated about what kind of energy is going into the grid and what we have access to. So what's the difference here? So shifting where and when we draw electricity can result in as much as 45 to 99% carbon reductions. So that's quite a lot. It's quite significant. So depending on the number of renewables in the grid, depending on where you are, which region you're working in, and where you're drawing your energy, where you have your server farms, the savings can be quite significant. So then we also have to talk about, okay, the business case and the legal case. So absolutely, when you create green software, you're creating a higher quality product that's leaner, cleaner, more fit for its purpose. Now, depending on what you're measuring, it can be difficult to make the business case because you're thinking in terms of long term. You're often thinking of very complex variables, but it's really important to try to understand that that this makes concrete gains for the business, concrete gains for clients and for customers. But when it doesn't work, and we know that it can be really hard, it's also important to lean on the legal factors, which is the laws that the EU has put into place. So now we have what's called the Corporate Sustainability Reporting Directive, the CSRD, which is a part of the European Green Deal. This is a directive that has come into play this year for most companies and for all large corporations next year. And basically what it requires is that we're reporting our carbon emissions as well as modeling our emissions for the future. And we also have to report things like our impact on human rights, as well as our governance. So it's quite important to be able to have tools in place so that we can measure and monitor these things so that we can be compliant with CSRD. So if your business stakeholders say, yeah, we know it's a good thing to do, but we're not quite sure, maybe not now, maybe, maybe it's too expensive, you can always say, well, actually, we have to do this. This is a legal requirement.
And so I think just like if you come away from Trish's talk and you think, oh, I really need to do some more testing of my software, just like starting testing, you've got to write your first test and move on from there. You've just got to start measuring your software in some way. It doesn't have to be perfect straight away, and small steps are better than none. I think there's a Chinese proverb saying the best time to plant a tree was 20 years ago, but the next best time is today. And so, why not start today or tomorrow, having a look and checking out sort of the tools available to measure and monitor, because measuring is the first step to being able to model and adjust and make changes and start to understand the use of your software. But before you can measure, you've got to understand the tools you're going to use to measure as well. And so that's what we're going to do a little later in this talk.
So yes, and so just for some context as well, we'd like to, right before we go into the impact framework, talk about the cloud carbon footprint. The cloud carbon footprint is an amazing tool. It's free and open source that ThoughtWorks developed with a client a few years ago. And it's something that you can use to measure your carbon emissions and energy consumption for the cloud utilization that you have. So this is, as you can see, a super nice way to capture some of these metrics. It comes with visualizations that you can show your business partners. It's a really, really nice tool. It's been in production for some time, so it's really off the shelf. Now, what if you want to measure more than carbon emissions from the cloud? That's the question. So what if we want, for example, to take in more different kinds of data, spit other kinds of data out, like what if you want to measure the impact of your supply chain logistics or your employee transportation, or give me an example for it can be like anything from what if we want to measure
I just got microbrewery in mind.
Yeah. Yeah, so what if we want something more customizable, modular, and flexible? So that's where the impact framework comes in.
Yeah, and also the kind of science of measuring climate emissions and things like that and how that relates to software is constantly evolving, and the parameters and variables you use and the calculations you make are always changing. And so the cloud carbon footprint does have those hard-coded, so you don't have the flexibility to change them as quickly, and you also need quite privileged billing permissions for any cloud resources as well. So the impact framework has a more granular and flexible way of doing it, but also kind of gives an open audit trail of what you've used so others can check it as well. I'll hand over this now, figure out how this works. Cool. So, yeah, the impact framework is developed by the Green Software Foundation, and like it says there, it's good for modeling, measuring, simulating the emissions of your software. We're going to speak about today and show how to understand it and just get set up, really. But if you imagine once you can measure your software, all the parameters which are in it, you could just switch to see, is the final output of carbon lower or higher if I, say, moved where I'm running my workloads and things like that if you're in the cloud. So it's kind of that starting point from where you can just let your imagination loose, really. But there are some main concepts which we just wanted to explain and get over for the impact framework. There's some really good documentation on their website, but they are still going, they made some recent changes to it, so documentation hasn't quite kept up and things like that. But the big four concepts really is the manifest file, the plugins, input, and also the impact engine which runs this. And you'll see a banana bread there, so apologies if you're getting hungry, although the lunches here are amazing. I mean, breakfasts here are amazing. But we're going to kind of do a bit of analogy to that, really. And so the manifest file and the impact framework is like the control center. And it's like if you want to cook peanut butter, banana bread, you turn to the page and you've got this, detailed recipe and everything like that. And so it breaks up into sections where you have all the metadata and the name of the manifest file. That's like the title, peanut butter, banana bread, and the little intro there. And then any recipe needs inputs and directions or ingredients lists. So that's your kind of inputs. And then you also need to initialize, what you're going to be doing. So that's like the equivalent of setting up your kitchen, turning on the oven, and everything like that. And so the inputs to the impact framework are like your ingredients list. So which, if you're in the cloud, you can do this, on-prem and things like that, but we'll be speaking about the cloud examples. Which cloud provider you're using, the region, the instance, and the utilization that you're seeing with your software. And then the directions are kind of the individual plugins. So these are the modular components which try and do as little as possible, but the output from one feeds into the input to the next. So that's like the directions in your recipe. So you've got your dry ingredients, you mix those all together, add your wet ingredients. You can tell I don't bake too much. But yeah, and then you do bake it at the end to have your delicious recipe. And the equivalent here is when you bring it to the impact framework and you want to measure your software, the first things you need are what they call observations. And really that's, first of all, what cloud you're using, what instance types, but then your utilization of your CPU, and then the name of the instance. And so that can then be gained either from you pulling that in whatever way, and that's actually the hardest bit. So they do have a mock observation plugin, so you can set up the rest of the framework just to get going, and you don't have to worry about your actual inputs of your software just yet. But then you can develop either bespoke things, there's a few custom importers from various clouds which you can use, and that pulls in the step one of the plugin. And then the next one is based on those things, it then plugins to calculate other things. So this is where I was doing a lot of ChatGPTing last week to find out what all these are. But essentially the thermal design power of a processor, it's essentially like the engine in your car. So the bigger your engine, if you're revving that car along, you're going to burn more fuel. And so the thermal design power is like the maximum heat generated by a processor when it's running at full capacity. So a bigger processor, the ones which might train ML models or whatever, they're really using up a lot of energy, and that heat's quite well correlated to energy. And so once you know that, you can then, and also from the cloud instance, you can also see how many virtual CPUs your app's using. So that's like in the cloud, it's split up into little slices, virtual slices of the processor. And so you can see how much you're using there. And then based on the servers that are in the cloud, how much your instance is, how many of those like little slices it has. And then there's another plugin called the What Time plugin, which is a really cool one. It kind of finds out for the region your workload's running what the grid intensity is in that region. So say you're in the region, California, where there might be a lot of sunlight and wind and renewables, your grid intensity is going to be a lot lower, maybe even zero. Whereas if you're in, say, North Virginia, a lot of coal burning, your grid intensity is going to be higher. So, but it can, look at which region, and it knows, like, there's an API which it can call out to and get live data for the specific time of day and what the grid intensity was at that time point. And so that's kind of the plugins which flows through there. Once you've got all those observations gathered, you kind of move on to some more, kind of these more built-in plugins which run through the calculations of essentially, this is where it kind of gets a bit like, sciencey, I guess. But you kind of go from, like interpolates any missing data, it'll convert your CPU to wattage and the power it's used, it'll generate some conversion factors, and then it'll adjust that. But it goes from final energy that's been used to carbon emissions. And these are all things that are in individual plugins, which are kind of the things in the purple there. And they are built in with the impact framework, so you get them for free. And these are kind of the off-the-shelf componentry. So you know that you can follow this pipeline, and this is a kind of a standard audited way of going from the top all the way through to the bottom, and you end up with carbon. You can change it, and as long as the input is correct for that plugin to use, you can like move these around and change, but this is kind of a good starting sensible default if you like. And that goes from carbon for operational carbon. and that's where we're stopping today. But if you can get access to information and metadata around the embodied carbon of the processes as well, you can feed that in. The Green Software Foundation has also done a lot of work around making standards, and they've come up with this SCI, or Software Carbon Intensity metric, and that's where you have the energy and the grid intensity divided by the workload. And like how you define that is, you know, application dependent, but it might be the number of API calls over a certain time frame and things like that. So you get a true measure of how much the energy carbon is being emitted for the workload that it's actually being used for as well. But essentially, once you've got those things, you stick it into the impact engine, and it's just like baking a banana bread. So you've got your ingredients in the blue boxes, you then follow step-by-step directions, and you end up with a yummy banana bread. And that's the equivalent in Impact Framework language. And so now I'm just going to do a bit of a code walkthrough. I'm not as brave as Trish, so not going to do a live demo, but got some kind of breakdowns, and then with a little pre-recording in a sec. So it uses Node.js. I'm a data scientist. I'm used to Python, so this was crazy for me. But you just install Node, and then you go to the IF is the top one there is the Impact Framework, and there's also loads of community-developed plugins too, which are quite fun. Some measure the carbon emissions in bananas and things like that based on a popular book. There's also more morbid metrics as well, but you can kind of do that there, and that's where a lot of the hackathon plugins that have been developed go as well. So there's the off-the-shelf plugins that are built into the framework one, and then there's also unofficial ones. And once you've got that, you can start building out your manifest file. And there's kind of 4 main sections here. You've got your project information and metadata, but the real heart of it is the plugins where they get initialized, so you kind of set them up. And then you use them in the pipeline, and that's where your inputs feed into too, along with any default configs you want to use. So the first one here is kind of self-descriptive, just what your manifest file is going to be doing. And then the plugins, I'll loop back around for this initialization step, but essentially then you line up and you tell in this like tree section of your impact framework the pipeline that you want to do. So the capitalized ones here are actually kind of placeholder plugins, if you like. So you somehow get a data importer, either one of the cloud off-the-shelf ones, or you might use mock observations to get going with it all, or you can develop your own. And then you cloud metadata based on your instance type. That's a lookup against what processors are used under the hood. So if you set up an instance in the cloud, you don't know what processor, AWS T3 large or whatever that is, but that metadata will be captured, and then that will also have the thermal design power for that, the number of vCPUs and things like that. And then the what time API is where it looks up, based on when you used and where you used your software, the grid intensity, and then you run through those calculate plugins to go from CPU to wattage through to energy and carbon, and energy to carbon is that last plugin, and you also include the inputs here, so that data import would be populating the input section here. And then the plugins in the initialization step, really there's kind of 2 things. So the first put is the output, and there's YAML or CSV, so that's an easy one. And then the plugins, this is an example of how you would kind of initialize the energy to carbon one. You just tell it the path, it's built in, and then you've got the input parameters, in this case grid carbon intensity and energy, and then the output parameter is carbon. And inside this plugin, it's quite basic. This one I think is just multiplying, but you're just kind of going through. But you can get more complicated plugins which need an API key. So the what time one, you just need to have set up an API key which is free to get the grid intensity at the certain time. And then once you've got your manifest file, it's just a command line tool to run the impact engine, which is the if run command. You pass it your manifest file and where you want to send the output. And this is where I probably have to press play.
You just press the next
Oh,
button.
nice. Thank you. Yes. So yeah, ignore my big Andy head in the right-hand side. But here, this is just like after a manifest file is set up. So that's the metadata. You can add some tags if you want. You initialize your plugins, and so we're just outputting as YAML. This is obviously a YAML format, the input as well. And then you just have your input plugin section. This demo is just for the calculate section, so it's doing a lot of the built-in plugins where there's multiplication to go from CPU factor to wattage, and then wattage to time duration. also highlighting the path here, so that just tells you it's a built-in plugin, so it comes with the Impact Framework, and it's not one of the community ones. And then it keeps going through to do these various plugins. Uses quite long. And you get to the final one, which is the energy to carbon. That's also built in, and this one takes input parameters as the grid carbon intensity, like I'd shown in the previous slide, and it outputs carbon. So the tree section is kind of the fun bit, and that's where you kind of have your pipeline that you want it to go, and then where your inputs get populated eventually. So in this case, they're the step-by-step, and this is where the order matters here. You can initialize them in any order, but then you put them there, and then you also, there's some defaults, because we're not using the API to pull in grid intensity or the CPUs or the utilization. We're just like, we're hard coding these defaults for the vCPUs, TDP, and grid intensity. And then the input bits, it's just 4 various components here, different utilization at different timestamps, basically. And so that's the full manifest file and what it looks like. And once you've got that, you can then just open a command line tool, run it, which I do now. But the reason is to show you what the output file looks like. So I'll just go through this. Yay, it's run successfully. And so the first thing that the output file hits you with is that it looks very much like the input file. And that's because it kind of is, but it kind of repopulates it with extra information. And if you don't specify the output file, it'll just print it to the console. But the idea being these manifest files are, shareable, so you can share your manifest file and they can run it themselves and it should repopulate. But it does populate it with this execution environment, so it tells you what was used to execute it. And importantly, it tells you the environment it was run on and the dependencies that were required and the versions of the Impact Framework as well. Yay, we were successful. And this tree section also looks exactly the same because that top bit is, and the inputs are also the same. But then what you get at the bottom for all that hard work is you get the extra bits populated. So it will still repeat the inputs. So we put timestamp duration and CPU utilization. It will also add in the default factors that we've added around thermal design, power, vCPU. But if we hadn't hard-coded them, it would have pulled them from the plugin and also populated them, along with some factors that it's pulled in. But then below that, these are all the things that it's then calculated by going through the pipeline, and with the end result of a carbon. So the units aren't given here, and that's one of the pieces of work in progress where it tells you what the units are in the plugin when you go for the details, but in the manifest it doesn't yet tell you have to add them as a comment, which is hopefully going to be worked on. But you can see that for each one of these workloads, it's given you a carbon, at which point you can go away, and there is an aggregation function as well, so you can do it for those things as well. Okay, so that was for one resource, but it's quite easy once you know that to expand for more than one. So look, that would be, say, one S3 bucket or, whatever, not S3, but yeah, one bit of workload. But essentially, it's this tree section and the inputs where we can sort of add extra information. So just like in the tree, there's children, that's just how many resources you have. And child 1 is resource 1, and you can see we've specified a pipeline and inputs for that resource. And then you would just add child 2 or child 3 and so forth for the extra information. And the inputs would always be specific for that resource. But although the pipeline here is inside child 1, you can also decide you want the same pipeline for all of your resources and keep it outside at just the children level, so you don't have to keep putting pipeline in every time. But that's part of the idea of giving the flexibility that if you have you think you need to calculate carbon or do something with a resource in a slightly different way, you can just put it into that and override what the inherited one is. So that's the main concept of the IF. We didn't talk about modeling, but essentially once you have that set up, all you have to do is change what region it is in the manifest file, and it would then calculate what the carbon is, and you can compare, if I move to California from North Virginia, is it going to save carbon? And if it does, why not make the switch? It's got a business case for that. And so just a note on this one, that it has, it's still got a tag on it as an incubator project. Companies are using it, but the reason that it hasn't been labelled as production yet from the Green Software Foundation's point of view is because they want, when it does go into production, that it'll be, backwards compatible and things like that, and they wanted the flexibility to, make the odd breaking change and things like that. There's been some big changes over summer, which took me a while actually to figure out for this talk, but it seems to be settling down, and they do have they want to go, to this as soon as possible. So, it has that production tag. So I would recommend experimenting and just having fun with it and seeing, getting used to measuring carbon emissions, whatever tool you decide to use on your software.
Yes, so thank you, Andy. It's super important that everybody goes out and tries this. And if you want to find out more, here's information. So you can check out the Green Software website, Foundation website. It's if.greensoftware.foundation, or you can use this QR code. And there they have all the tutorials that you'll need. There's also the Green Software Foundation repo on GitHub. And you can also join a Google group community. This is something that's super helpful if you want to just ask questions, meet other people who are trying things out. And then finally, there is a wonderful free course that's put out by the Linux Foundation. And it's basically green software for practitioners, all of the basic core concepts and ideas for how to be a green software practitioner. So it's really, really nice to go through that and understand the whole space. And also, you don't need to be necessarily a developer, so you can even have your project manager take that course. So again, don't forget to tell others. Tell the story of what you're doing, what you're experimenting with. This is a super new emerging field, and it is really, really critical and really important that we all do this. Do it. Go out and tell your stories, because we need more stories. We need more use cases. We need more models. We need more understanding of how people are doing this, how they might be failing, how they might be succeeding, so that we can all do this and solve this problem together. So how do we do this? We do this through storytelling and metaphor. We understand what problems we're trying to solve, and we understand what's in it for us, for them, for us, for all of us. So yeah, and with that, thank you so much.